General math students, in this video we're going to do some more Pythagoras theorem questions, but they're going to be in 3 dimensions. So you can see this box down here on the bottom right is drawn obliquely. So it's a 3-dimensional shape, but it's being represented on a flat page in 2 dimensions. So the question is, what's the longest needle that will fit into that box? So that means we need to know the distance from, say, here to here, that bottom corner up to this corner here, because, I mean, you could use any of opposing or diagonally opposite corners, but this is just one. That is the longest distance between any 2 points inside that box. So essentially we're trying to find the length of this blue line I'm just placing in here. So this is going to be a 2-step process. First, what we'll do is calculate this red dotted line I'm putting across the base here. So see how I've put that in there, that red dotted line. And I'll shade this triangle in. That forms a right angle triangle. If I was to just draw that flat on the page, so sort of take it out of this diagram, this 3-dimensional diagram, and draw it in 2 dimensions, it would look like this. Now, I'm not using a ruler here, which is naughty, but I'm going to do it anyway. You guys should always use rulers, of course, but just to show you this situation. So what I've got here is the 9-metre base and the 6-metre base, and I'll shade this triangle just to show you that we're using the same red shaded triangle as from this diagram. Just make that look a bit better. So what I'll do is I'll calculate this length here first. I'll call this x1. So of course x1 is the hypotenuse for this triangle, so I'll have a plus in between the 2. Okay, so in this case we get, if we put that into the calculator, we find that the length x1 is 10.8 metres. Righto. Now I've got x1, so that means I can draw another triangle, a second one, and I'm going to take this triangle out of this diagram. Here's the blue line, which I'll call this x2 first. We want to find x2, that's the longest needle, that blue line. So I'll draw that here. So I'm taking this one out of the 3D diagram. I'm going to draw it in 2 dimensions on this page. So we've got x2 that we're trying to find, and we have a 2.5 metre. This is the height, this one here, 2.5 metres, and then we found x1 along the base, which I represented with this red dotted line. So this red dotted line is the same as this one here, and we found that that was 10.8 metres. So the second calculation here is going to be the one that we're after, the longest needle that would fit into this box. Once again, it is the hypotenuse that we're trying to find, so we'll have a plus in between the 2 values. So if we put that into the calculator, we get 11.09, I'll say 11.1 metres. Okay, so you're going to have to use your abilities of visualization and spatial awareness to have a go at some of these 3-dimensional problems. But we'll have a go at the next example, which involves a sky lantern, in the next video before we embark on these 3-dimensional problems.